So this video is about why the charge conjugation of a spinner is written in this fashion. So if we have an original spinner psi and you charge conjugate this thing, you come up with a spinner which is usually written in this manner. So this is just an imaginary number. Gamma 2 is the one of the Dirac matrices, and psi star represents the complex conjugation of the spinor psi. So one could ask, why is charge conjugation written in this fashion or not something else? In this video, I try to answer this question. To understand, first you have to realize that the whole point of charge conjugation is to come up with the spinor of the antiparticle, right? So the antiparticle has, if the spinor psi has charge associated q, the antiparticle should have charge associated minus q. So as a result, if the spinor satisfies the following equation, Dirac equation, given by this, where gamma mu's are the Dirac matrices and d mu, the covariant derivative, is written in this fashion. Del mu plus iq mu. Mu is, so this is the Dirac equation coupled with the electromagnetic field. Mu represents the electromagnetic field, and q is the charge of the spinor side. All right. So if the spinor side satisfies this equation, the antiparticle spinor should satisfy the following equation, where we do not know what psi prime is, but we do know d mu should be, and it's del mu minus iq mu, because we're dealing with antiparticle, and the antiparticle should have charge minus q, which is evident from here, the definition of the covariant derivative. So d mu prime. Now, what I have to do is I have to show that this psi bar, so psi star, psi prime. This psi prime is given by I gamma 2 psi star. If psi prime is given using this expression, and we can show that this expression satisfies this modified equation, then we are done. So let us proceed. So we'll start with the original equation, the spinor psi coupled with the electromagnetic field, and you have to take the complex conjugate of this equation, m acting on psi, and you take the complex conjugation of this 0, and we have minus I gamma mu star d mu star minus m acting on psi star is 0. All right. But notice one thing, that being d mu star is nothing but del mu minus iq a mu, right? And this is basically d mu prime. So we end up with gamma mu psi, sorry, star del mu prime minus m acting on psi star, which is 0. We are almost we're really close to the final equation, but notice one thing: the final equation should contain gamma mu only gamma mu, right? There should be no star in the final equation. So what we have to do is we have to multiply this thing with I gamma 2. Now, why am I multiplying the whole equation with I gamma 2 will be clear in a bit. Bear with me. So we do that. We multiply this equation with I gamma 2, and we have mu star d mu prime minus m star 0, and you have I square minus I square, so that would be a plus 1, and you are left with m acting on psi star is 0. Now we're going to use one identity, and that is gamma 2 gamma mu prime is minus gamma mu gamma 2, right? And this is the place where it will be clear, become clear to you by we're using gamma 2. It is only when we are using gamma 2 that we can write this identity. So how do you prove this thing? Well, you can work in a particular representation, Clifford algebra representation, and let's take the representation to be the Dirac representation, right? The Dirac representation, and in this representation you have gamma 0 to be I2 0 0 minus I2, and gamma i's are given by 0 sigma I minus sigma I 0. Now notice one thing, if you take the complex conjugation of gamma 0, it does nothing, and you are given the gamma 0 back. But if you take the complex conjugation of gamma i's, what you have is you have minus gamma I when I is 2, and gamma i's when I is not equal to 2, because sigma 1 is given by, if I remember correctly, this expression sigma 2 is given by this, and sigma 3 is given by 1 0 0 minus 1, right? So this doesn't change, and this doesn't change under complex conjugation, but this thing changes, and this thing changes into minus sigma 2, and you have this thing consequently. All right, given this information that gamma mu star is minus gamma mu when mu is not equal to 2, and gamma mu when mu is 2, we can proceed with our proving the identity that 2 gamma mu star is given by minus gamma mu 2. So you start with you do case by case analysis when mu is 2. So this thing is what you have, and we know this is minus gamma 2, and this, and we take this thing to the gamma 2 because mu is equal to 2, and right. So for mu is equal to 2, you have proven this identity, and still have to do the best cases. So when mu is not equal to 2, start to be gamma 2 gamma mu, but we know one thing, that is the Clifford algebra is given by the following expression: gamma mu, and the commutation of gamma mu is given by 2 g mu nu, and this g mu nu is the Minkowski metric, and when mu and nu are not equal to each other, you have 0, and as a result you have this following identity, right? And when mu is not equal to mu, and we're going to use that. And we can write this expression to be minus gamma mu gamma 2, and that sort of proves it. That proves the following identity for all the cases of mu, and we're going to use it. So remember what our original equation was, and this thing basically. Let me copy paste this thing. Oh, my bad. Yeah. Yes. Paste. So. Yeah. I guess just got transported to some place where I can access it. Anywho, so let me write it down. Gamma 2 gamma mu star. Have my bad. Gamma 2 gamma mu star. That's m. Gamma 2 acting on psi. That should equal 0. I guess this is the equation. Oh, sorry, as a derivative. So yeah, that should be I gamma 2 here, right? Yeah. Here and you have this covariant derivative. All right. So we proceed from here. We replace this thing with I gamma 2 gamma mu gamma 2 t mu prime minus I m gamma 2 acting on psi star giving mu 0, and you shift gamma 2 to its right and gamma 2 star to be 0. Next, we can take minus I common, right? Yeah, so prime and this is I gamma 2 psi star. This thing is 0. So that should be minus I down below. And mu prime m I gamma 2 psi star 0. And again, if you take I common from here, we'll have, or okay, we could just multiply using I, and you're left with gamma mu t mu prime plus I m I gamma 2 psi star giving 0. That should be a minus in here. Let me check. So what were we set to prove? Let us go to the original equation. We were to prove this thing, right? We were to prove this. So there should be an I. Yeah, so we're going in the correct path. So yeah, so take this positive, so multiply with minus. So yeah, let me erase this thing. That's minus, right? Yeah, so you can see the spinner that satisfies this equation is given by minus I gamma 2 psi star, right? And this operator is for the antiparticle. As a result, we can safely say that this spinner, this modified spinner, is the charge conjugated spinner of the antiparticle. And so we use minus I gamma 2 to transform the to charge conjugate the Richard spinner.